Okay, picture this. You're an explorer, completely stranded in the vast, frozen emptiness of the Arctic. Your food is gone, your hope is just about gone too, but then you manage to hunt the absolute king of this domain, a polar bear. It feels like salvation, right? But here's the thing. Inside that bear is a biological booby trap, a single organ so toxic it can kill a healthy person with just one meal. And this isn't some old wives' tale. It's a very real, very deadly scientific mystery that we are going to unravel right now.
And this is not a new discovery. For well over a century, people who ventured into the polar regions and ignored the local wisdom, well, they learned this lesson the hard way. Back in 1912, a Russian sailor named Alexander Conrad, he was part of this doomed expedition, and he wrote down exactly what happened. He gave us one of the first written accounts of the awful, horrific consequences of this one desperate meal, a danger that the Inuit people had known about for generations. So let's start with the mystery itself, because what Conrad and so many others went through, it wasn't just a simple case of food poisoning. No, it was something way stranger, a brutal, consistent, and very often fatal reaction to eating the organ meat of an apex predator. This has been documented time and time again across different expeditions, almost like a grim footnote in the history of exploration.
When you look at the timeline, a really chilling pattern starts to emerge. You've got Conrad in the Arctic in 1912, okay? Then, just 1 year later, on the complete opposite side of the planet, in Antarctica, a very similar tragedy happens. Two explorers, Douglas Mawson and Xavier Mertz, they're starving and they eat the livers of their sled dogs. Mertz dies in absolute agony. The common link? Apex predators that feast on a rich marine diet. And this whole tragic history is in such stark contrast to the indigenous peoples of the Arctic, whose traditional knowledge, built over thousands of years, specifically warns against eating these organs. For them, it was a non-negotiable rule for survival, long before science could even explain why.
The accounts from these expeditions, they all describe this terrifyingly consistent set of symptoms. It kicks off with an unbearable, splitting headache. Then dizziness, vision starts to blur, nausea and vomiting come next. The victims become incredibly drowsy, irritable, and then, one of the most gruesome signs of all appears, their skin literally begins to peel off in sheets. For anyone who ate a large enough portion, the final symptom was, tragically, death.
So how are we going to solve this? Well, here's our roadmap for this explainer. We're going to move from that historical mystery to the scientific culprit. We'll find the unlikely poison, we'll figure out what makes a lethal overdose, and we'll trace it all the way back through the Arctic food web. Then we'll get into the evolutionary mismatch between polar bears on us, and finally, we'll understand the absolute biological limit this whole story represents. You know, the culprit behind this whole thing isn't some weird Arctic toxin or a strange bacteria you've never heard of. Actually, it's a compound that our bodies absolutely need to live. The poison is a nutrient. And that paradox, the fact that something essential can become so incredibly lethal, is what makes this whole case so fascinating.
The killer's name is retinol, but you probably know it as vitamin A. We need this stuff for pretty much everything: our sight, our immune system, healthy bones, even the basic process of our cells becoming what they're supposed to be. In the right amount, it's a cornerstone of life. But when your body is flooded with it, it triggers a toxic chain reaction called hypervitaminosis A. You see, the key to any poison is the dose. And in the Arctic, the dose can get astronomically high.
Now, to really get the danger here, you need to know that our bodies get vitamin A in two different ways. From plants, like carrots, we get carotenoids. Think of these as precursors. Our body's super smart, it only converts them into active vitamin A when it needs it. It's a regulated system with a built-in safety switch. But from animal sources, especially liver, we get what's called preformed vitamin A. It's already in its final active form. Our body has no safety switch for this. It just absorbs all of it directly. And that's where the danger lies. Okay, so we've identified the weapon, preformed vitamin A. Now we need to understand just how powerful it is. Exactly how much of this vital nutrient does it take to flip the switch and become a deadly poison? The answer is, well, it's genuinely shocking.
Before I throw some numbers at you, just take a second and guess. We're talking about a vitamin we need every day, not some kind of heavy metal. How much could a person possibly need?
For an adult male, the recommended daily amount is about 900 micrograms. That's micrograms. So it's less than a single milligram. It's a tiny, tiny, precise amount that our bodies are built to handle. Keep that number in your head, 900 micrograms.
This chart right here puts that number into terrifying perspective. 100 grams of beef liver, which everyone knows is rich in vitamin A, has about 6,500 micrograms. That's roughly 7 times what you need in a day. Manageable. Cod liver is way higher. But then you get to the polar bear. 100 grams of its liver contains around 7.5 million micrograms. That's not just more. It's over 8,000 times the recommended daily amount in one small serving. It's a biological scale that our physiology just cannot handle. So to put that into real-world terms, it's estimated that eating just 500 grams, that's about a pound, of polar bear liver delivers a toxic and very possibly fatal dose for a person. A single desperate meal can unleash a catastrophic overload that the human body simply has no defense against. So where in the world does this insane concentration even come from? It's not like the polar bear is brewing a poison on purpose. The bear is just sitting at the very top of a unique and incredibly efficient food chain that acts like a giant concentrator for this one specific vitamin. The scientific principle that's going on here is called biomagnification. This happens with stuff that's fat-soluble, like vitamin A, which means it doesn't get flushed out of the body easily. Instead, it builds up and gets stored in fatty tissues. So when one animal eats another, the predator absorbs the prey's entire lifetime accumulation of that substance. Let's follow the vitamin A up the chain. It all starts with marine algae that have the precursors. Then, small fish and krill eat huge amounts of that algae. Next up, seals eat enormous quantities of those fish, and since vitamin A is stored in fat, it just builds up in their super rich blubber. And finally, the polar bear, the apex predator, eats many, many seals over its lifetime. All of that vitamin A from every single seal gets passed up and becomes massively concentrated in the bear's own liver, which acts as its main biological storage tank. And that brings us to the final, fatal showdown. This isn't just about chemistry, it's about evolution. It's a story of two species, one that is perfectly adapted to thrive on this chemical overload, and another whose biology is completely, dangerously unprepared for it. So why does the polar bear even have this trait? Well, it's not just a fluke of its diet. It's a critical adaptation. The polar bear's body is this incredible piece of Arctic engineering, evolved to safely handle these insane levels of vitamin A to support its high-fat metabolism and just survive in the brutal cold. Humans, on the other hand, we evolved in places where vitamin A was often hard to come by. Our bodies are designed to be incredibly efficient at absorbing and storing it to stop us from becoming deficient. But when we're suddenly faced with a massive, overwhelming abundance, that very efficiency becomes our downfall. It's a catastrophic evolutionary mismatch.
So what's actually happening inside the body when this goes down? First, this massive dose of retinol just floods the system. Your liver is instantly catastrophically overwhelmed. Think of it like this. The special proteins that carry vitamin A around are like taxis, and the vitamin A molecules are the passengers. Normally, it's a pretty orderly system. But here, the city is flooded with millions of passengers all at once. The taxis are all full, which leaves these dangerous, unregulated passengers just roaming the streets, causing chaos. This free-floating vitamin A then starts messing with the expression of hundreds of genes, causing a complete and total breakdown of normal cell function.
And this systemic failure shows up in some really horrifying ways. The excess vitamin A paradoxically attacks your skeleton. It actually stimulates the cells that break down bone while stopping the cells that build it. The pressure inside your skull spikes, which causes those crushing headaches and blurred vision. The liver itself suffers massive damage. And the truly terrifying part, there is no antidote. You can't reverse it. Doctors can only provide supportive care and hope the patient's body can slowly, painfully clear the toxin over weeks or even months.
All of this leads us to a really powerful conclusion. The case of the polar bear liver is so much more than just a survival curiosity. It is a stark, unforgettable lesson about the unforgiving and absolute limits of our own biology. And let's be perfectly clear, there is no way to cheat this system. You can't cook the poison out. The danger isn't from bacteria or some toxin that breaks down with heat. The danger is the retinol molecule itself. Its chemical structure is the hazard, and no amount of cooking is going to change that fundamental fact. The toxicity is baked right in. So what's the big takeaway from all this? This whole story, where history, biology, and chemistry all point to a single deadly conclusion, it teaches us a really profound lesson about the line between what keeps us alive and what can destroy us.
The final word is really this. The warning to avoid polar bear liver isn't a suggestion. It's not some cultural taboo you can debate. It is an absolute biological law, one that's written into the unchangeable code of our own metabolism. It's one of science's clearest reminders that the line between a nutrient and a poison is not a matter of what it is, but how much there is, and that beyond certain limits, nature offers no second chances.